Hello YouTube! This is Team Peränurkka's first full English video. If you are Finnish viewer, check out the last 5 or 10 minutes of this video. I will be explaining everything in Finnish also for Finnish viewers. So, first of all, this is video how to break in or play in your subwoofers. So what do you need? You need one big monoblock, like Formula X Focus bifocus acoustics. Then you need decent amount of battery power. I have 3 Yasa L3590s. It's 90 amperes per battery, so I have roughly 300 here, and I have a charger here that charges the batteries. I have already one subwoofer drived in or braked in. Then you need something to calculate your battery power, so you don't play in less than 12 voltages. Then you need something to calculate how much voltage you are giving to the subwoofer. This is calculated from the amplifier's terminals. The voltage of the battery bank is calculated from near the amplifier's terminals also. Then you need a clamp meter to calculate how much current you are giving to the subwoofer. I have this unit T here. It's pretty good, it's cheap, buy it from eBay. Well, I bought it from eBay. Then you need a working car audio system. I'm driving these in my Volvo, so I have to run every now and then to the front of the Volvo to check out the volume, but after I get the volume right, it will be just waiting and calculating and changing the song. First of all, you need to have a pretty good idea what you are doing, and I'm going to explain here. So these are the basics that you need. Also, you might need a infrared thermometer. This is with this you can calculate how much Fahrenheit or Celsius your subwoofer coil is at, so you don't burn in the coil, you don't give too much power into it. So play safe, and I play at roughly 40 degrees. I don't know how much that is in Fahrenheit, but we'll see when we drive in. Then you need something to put your measurements into. We are measuring the impedance of the subwoofer, so you need voltage from your subwoofer. Then you need current from your subwoofer also, and you get impedance, and this is what we are calculating here. Before I put the subwoofer to drive in, I'll try to explain how you measure and what you do. So here comes this notebook handy. We start at playing roughly at 50 Hertz. This driver's frequency is 30 S.8 after 6 hours break in, but we are driving it in roughly in 2 hours. So first we start at 50 Hertz, we play it at 15 volts, and after a 10 to 20 minutes we turn it up to 25 volts, and after roughly 40 minutes we turn it up to 30 volts, and at this point we should be somewhere 35 to 32 Hertz, and with my system we cannot play 30 volts at 30 Hertz, so we turn it down a little bit to 23, I think it was, and play it as long as we need to, so we can bring the frequency down to 30 Hertz. So how do we know when it is at the song we are playing for? When we have a song like 50 Hz here playing, and we have impedance at 11 ohms roughly, when the time goes by, here is impedance ohm z, and here is time t. When the time goes by, when we are playing the same song, when the time goes by, when we are approaching to the Fs, let's say Fs is here. When we are approaching the Fs, the impedance will rise slowly. But when we reach the Fs points, the impedance of the subwoofer will go down pretty quickly, like so. And we'll need a calculator to calculate the impedance as we go by, and we keep on checking the impedance every now and then. If it is still in rise, we let it play. If it stays flat, we wait, and if it starts to turn down, at that point we know that the Fs has turned down from the 50 Hz, that song we are playing. So when the impedance starts to decrease, we change the song about 5 Hz down, and we start over again. So simple as that. Now let's see how it's made in. That's about theory. Let's now put the subwoofer in and let it drive in. So I'm using chains to hold my subwoofer down, and let's wind this pretty fast, as I don't want you to wait too long until we get it going. So let's do it. I have here Focus Acoustics 10D2 subwoofers, and just to show you that I have already one driven in. I'll show you that I'm taking these as a new. I have never opened these before, so it should be at factory frequency. So let's put it in. So as you can see here, I have put this subwoofer into parallel mode. So we have two voice coils, one here, one here. Of course they are there, but terminals are here, and I put the positive on the positive and the negative on the negative, and run one wires into the amplifier. Now let's hook it in. Now, as you can see here, we have the subwoofer hanging over our system. I'm using chains because it's lightweight and easy to use, and makes the subwoofer hold pretty nicely here. Only thing that this does is that when you go less than 35 Hz, these chains starts to resonate, so it starts to bounce a little bit, but that's why we turn the volume down a bit and drive in safely the last few hertz. Now it's hooked up. We can check here that we have let's check at the terminals that we have a 1 ohm connection here. Yes, we are correct, 1 ohm roughly, but yes. Then we turn that back into current mode. And now we are ready to go. First of all, we start with little excursion, then we turn it up. So let's hit the song. As you can see, my car is under heavy construction here. I have just painted the pot and it starts to look pretty nice. So let's turn it up. So sorry about the noise, but we are still on the go. We have now roughly 12 volts. I said that we should be going roughly at 15, so I go and turn it up a little bit. Let's check this first, fast. Let's calculate. We have 12 volts. Oh, blimey. And we divide it by 3.4 and get roughly 3.65 ohms. So as you can see here, our current is starting to rise. We can check fast that 12.42 divided by 3.43. We are already driving it in, and we are now lowering. The impedance is now lowering down. Well, that means that we have already reached the frequency of the subwoofer and we are going away from it. So the song that I was playing is now 55 Hertz. So we can easily go and change the frequency down to 50 Hertz, and let's see if we are rising or lowering. Now we are back. As you can see, we lowered the frequency by 5 Hertz, and let's check fast. We are now at 6.11 ohms, and as we have the small 10-inch subwoofers, it will be really difficult to check the temperature of the coil, but I will check it here. So we are now at 25, 26, so that's about 75. So we are at 26 Celsius, our voice coil, and we have 12 volts going into. So let's check fast again, where's our impedance at? So we are lowering down 5.89 ohms. That means that already this brand new subwoofer has a frequency lower than 50 Hertz, because the impedance is decreasing already. So let's go down for 5 Hertz. Okay, we are now at 45 Hertz, like so, and I will check this out. 24. What the fuck? 12.4 divided by, so it's 0.98. So we are now at 12.98 12.65 ohms. As you can see, the impedance has rise a pretty damn much, so I think that we are now at least close or closing to the frequency of the subwoofer. Now the subwoofer is now at the free air state, and the frequency will be roughly correct. And let's just check it out. Wait for a second here and try again where the impedance is at. Now I am playing already at a very low volume because divided by 994, 0.994, 12.4. So we are playing at very low volume now, because we are trying to find out where we are. Are we under the frequency of the subwoofer or are we over it? So as we play already, I can see that the impedance is lowering down all the time. So that means that we are the song that we are playing is higher than the frequency of the subwoofer. So again, let's lower it down for a 5 Hz and let's check it out. So we are now at 40 Hz. As you can notice, our chains are starting to keep noise, and as we go by, as we increase our volume, it will be more louder and louder, and you will be having more difficulties to find out what the hell I am saying, but bear with me. Let's calculate fast here. 12.34 divided by 975, 2.975, 12.64, 5. Okay, we are now at 12.65 ohms. Everything is okay. We are using a very small excursion here because we want to break in slowly. We don't want to break the subwoofer, we want it to break in. As we go by, as we find our frequency that we want to play, we increase the volume a little bit. Then we played for roughly 40 minutes. Then we increased the volume very much so we can get them as much as excursion as we want, and we'll break it in with that excursion. So fast again, let's check it out. We are now increasing, so that is a good thing. So what that means? Well, as I explained earlier, when we are approaching, when we have the song, I'll draw it again. We have here, like so, we have a time here in seconds. We have impedance, that is ohms here. We have a subwoofer's frequency here, that is question mark because we don't know it. We don't actually need to know it because we are lowering it down and it lowers every time we play. So as we have a song that we play which is, let's say, 40 Hertz. Now we have 40 Hertz. Let's say here is 40 Hertz, and as we are well, that does not work in this diagram. So when we are approaching the frequency, the impedance will rise slowly, but it rises until we reach the frequency of the subwoofer. The subwoofer frequency lowers all the time. Every time we play, every second we play, it lowers by fractions of a hertz. So it's really hard to determine where it is as we break it in. So as we have a rise in our impedance, we know that we are closing to the frequency of the subwoofer with the song we are playing. But when it starts to decrease, it will decrease quite rapidly. And then we know that we have gone past over, the subwoofer has gone past over the frequency that we are playing, so we need to lower down the song that we are playing. Well, that's 2 times I've explained it already. I hope it has helped you or teach you something. I need to work it out every time I do these things, because every time I start to drive in a subwoofer, I'm keeping that in mind, that if it goes up, it's okay. If it goes down, we need to go down in song. So let's calculate again. We have 12.936 here, and divided it by 0938, and we have 13.117 ohms. That means that the frequency of the subwoofer was 40 Hz, but it has now started to decrease from the point it was just a minute ago. So we know that we are now roughly at 40 Hz with this subwoofer, and we are trying to driven it down to like 30 Hz. Actually, after 6 hour break-in, it should be 30.8, so we need to turn it down to 30 as quick as possible. So now we need to already lower the song, and let's check it out. So we are back, and we are now at 35 Hz. And let's calculate fast. 12. Well, it's not necessary to calculate it fast, but I want to calculate it fast because I can show you how it works in real life. 6.44 ohms. So our impedance is now 6.44, and I think that we are now reached the point that it will be much slower to lower down the frequency of the subwoofer, so we need to turn it up a little bit. So we turn it up to 20 volts, or at least near that, so we can check it out if it starts to decrease or increase. Okay, already we are at roughly 15 to 20 millimeters in excursion, and we are currently at 20 volts, so we can calculate here 19.42 divided by 3.65. We are at 5.32 ohms. Now keep in mind that when we increase the volume, we need to calculate the reference numbers before we need to calculate the reference numbers, because the calculations is not correct when you increase the volume, so we have something to reference into. So as I calculated 32 ohms, now I wait a little bit and then I calculate it again, so I can see if it's rising or decreasing. And now we can check the temperature of the voice coil, like so. We are now roughly at 30 degrees, and for your Americans I can show you we are now at 85, 87, 88 Fahrenheit, 90, 90. Let's check it out at 32. So we are very safe now. I can push it up to 54, 55 Celsius until it starts to smell. The voice coil has a coating on it, and the coating starts to melt at roughly 60. It actually depends on the manufacturers, but I have noticed that 54, 55 is the point where the voice coil starts to stink a little bit, and at that point you need to turn it down a little bit. But we are now at 32 something degrees, so we are very safe, and we are just starting to breaking this in. So let's calculate again. We have 19.43 divided it by 3.25, like so, and we are now at 5.98 ohms. So at this point I will leave this here for a half an hour or so, and we will be back then to check it out how the impedance has risen, increased or decreased. So see you back soon. Hello YouTube, now we are back, and it's been a little over half an hour. So let's calculate again here how much we have. 19.52 divided by 2.2. We are now at 8.87 ohms, and it keeps decreasing. The currents keep decreasing all the time. So I think that now we have reached the point that we can turn up the volume up to 30 volts, so we can really start to drive in this subwoofer. So let's turn it up. So we are back here, and let's fast check how the voice coil, the temperature rises. It is now at 43.4, 44, so that's 111 Fahrenheit. 40. We need to lower it down a notch. So what I noticed there, that was the voice coil started to smell a little bit. So that tells me that we are reaching too high temperature at the voice coil. So I'll immediately lower it down from the CD player so that we don't burn the voice coil. We are now at 25 volts, and I think I'll let it cool down a little bit. It cools down quite fast because the voice coil moves so fast and such a long excursion, so that it cools down the voice coil pretty fast. But we can now turn it up from the amplifier. What I noticed there, that was if I turn it up from the CD player, it will maybe start to distort a little bit. So I don't want to burn in the coil, so I just turn up the amplifier's gain at this point to reach the 30 volts. now this is pretty here. Like so. The voice called does not smell. That is good thing. And the temperature is 40, 41, 40, almost 42 degrees. That is okay, still in the okay zone. So now we can calculate 29.98 divided by 3.91. We are now at 7.67 ohms, and as we can see, it started to decrease. The current started to decrease pretty fast. This tells me that it has gone over the frequency of the subwoofer has gone lower than the song we are playing. So I can calculate here fast that 29.99 divided by 3.64, it is 8.2. Oh, wait a minute. Sorry, I really I explained it wrongly to you. I thought that it was decreasing so rapidly that it has gone over the point, but it has not. So we still keep watching the impedance as it rises, as we are closing down more rapidly with this high execution than before. That's why it was faster than the normal. Normally it is if we use lower voltages. Now we can calculate how much power goes to this subwoofer by powering up 29.99 times 3.36. That is currently 100 watts goes into that speaker with the impedance of roughly 9 ohms. Remember that we calculated it at 1 ohm before we started. So we are now giving pretty much how much this amplifier can give in 1 ohm. I think the gain is already set quite high. So now we are just waiting it to break in. As we can see, the excursion is pretty violent. Actually, I'm not really sure how much you can hear me. But we can watch here the excursion. It's 4 centimeters. Perhaps maybe more. If I have here something. Well, here is a Maxell 4 GB USB drive, pen drive, so I can place it here. Well, maybe here. So it's hold on. The excursion is almost as long as this pen drive. Now why that stopped, I have 10-minute songs that are playing in repeat, so the song stops every now and then it starts all over again. Okay, as we watch here, it still keeps decreasing. 30 divided by 2.98. We are now at 10 ohms, so we just keep on playing and we'll see you roughly at half. So let's give it a 15 minutes. See you back then. So hello, back again. Clock is now roughly at 6, half to 6, and we are now, I have noticed that our current is now rising, so we can calculate here 30. So we are now at 10 ohms, and our song is still 35 hertz. Like so. But as we wait here a little bit, we can actually see that the current is rising, so we can calculate 30.03. That the impedance is now decreasing, as I calculated now 10.43 ohms. Now we cannot run this system at 30 hertz with 30 voltage, because it will start to vibrate so much that it is just unbearable to watch. So we still keep this So we still keep this 35 hertz until it is more close to 30 hertz. Welcome back. We are now roughly at 2 hours. Let's fast calculate here. We are now at 13.34 ohms, and we are close to finish this driving in. We just need to wait until the frequency drops below 30 hertz, and when we notice that this 13.34 starts to decrease, then we know that we are reached our goal of 30 hertz. And by checking this, by keeping eye on that current, we can calculate when we have reached it. So let's take a fast recalculation here. So we are still at the same level, but let's see in half an hour what happens. Yes, welcome back. I made these English videos yesterday, but I forgot to make the last video of them, so this is the last video of this part. So after you have checked that the impedance starts to decrease, you have finished your break-in time, so your subwoofer frequency is below the frequency that you are playing. After that, you can always break in it under 30 Hz. It depends on the components of the subwoofer, but it is not necessary to break it in even further, as you have reached, this subwoofer's FS is 30 Hz, and I have now reached 30 Hz on this subwoofer's FS, so I can put this on my wall and play it out the rest of the FS if needed. What we can notice now, that if I stop this song playing, now the subwoofer is easily moved by hand. You only need like little soft touch to move it around. It is very flexible. So this is the meaning of the driving in the subwoofer. Without driving in, it is stiff and it does not play every frequency as it should be. Now this was Focus Acoustics 10D2 break-in video, and it starts to rain here, so I'm getting inside. Thanks for watching. Subscribe.